today's lesson, we're going to go ahead and go over some slope applications and how slope can be kind of converted and used to look at different word problems. So some things I want you to remember. Slope is the steepness of a line, so it's the rate of change between 2 points. A ratio of the vertical change, called the rise, over the horizontal change, called the run. We're going to write this in a fraction in the simplest form. You will also see it as a decimal as we get working further into the algebraic kind of information, and as we move towards everything we need to know for Algebra 1 to learn all of our prerequisites for that. But understand I can also take any of those whole numbers that I have and turn them into a fraction, because remember, any number can be a fraction if I put it over 1. So the variable for slope is m. Okay, remember, so it's going to be rising action. So does it go up or down? Over run, so left and right. So m equals rise over run, which also equals, if I have 2 points on a coordinate plane, okay, take group number 1 and group number 2, take the x or the y value from group number 2, subtract the y value from group number 1, put that over the x value from group number 2, and subtract that from the x value from and subtract the x value of group number 1. So remember this formula here, rise over run, m, rate of change. If it's a proportional graph, you're going to hear constant of proportionality. All those information, all those terms are talking about slope. They all mean the same thing, so that is slope. Okay, so here is a way we might need to know some information about slope to solve a problem. So the table below shows the high temperatures in degrees Fahrenheit of a city during the first part of June. So here's the date, and so this is June 1st, June 6th, June 8th, June 14th. Here are the high temperatures, so 72, 76, 84, 86. So they want me to find the rate of change in high temperatures between June 1st and June 6th. Well, this table, if I look at it, kind of looks like an ordered pair, right? I have a date, I have temperatures. I want you to look at this table and think of how would I graph this? So what would be the information? So I would have x and y, right? Because if here is my graph, so I'm going to have my x values here and my y values, I would probably have the dates, right? 1, 2, 3, 4. I'd probably go all the way up to 30, and these would be dates. And then if I would graph that, the y values would be the temperature, right? So high temperature. So now that you look at it and kind of visualize it this way, right? So 1 would be, let's say we have 60, 70 here, 80. Maybe you go in smaller increments. Really doesn't matter. But so the first would be, 72. There'd be a dot here. And then if I want to find the rate of change, so I need to find the slope between June 1st and June 6th. Well, I can now go ahead and go date, temp. I'm going to make a table this way. It'll help me a little bit. June 1st, so on the first, on the 1st, it was 72. And on the 6th, it was 76. So here's an ordered pair. Here's an ordered pair. Okay, and I said date was X and temp was Y. So now let's remember the formula I need to use. So slope equals y2 minus y1 over x2 minus x1. So here's group number 1, here's group number 2. So y2, so 76 minus y1, which is 72, over x2, which is 6 minus 1. Now I'm going to leave it in fraction form to solve right now. So 76 minus 72 is 4, and 6 minus 1 is 5. So 4 over 5 is my slope. And if I put that into a calculator, I'm going to have 0.8. And what does that mean? That means that about the temperature changed 0.8 of a degree a day. That is from each day. That was the increase from the 1st to the 6th. The temperature increased 0.8 of a degree. So now B says, find the rate of change in high temperature between June 6th and June 8th. Well, if the information on the way it shows me the chart right here is kind of confusing, write it in a vertical table like this. If you understand it, that's fine. So I'm going to use this table here and not rewrite it. If you need to rewrite it, please do. So June 6th is here and June 8th is here. So I'm just going to write my ordered pair. My ordered pair are 6, 76 and 8, 84. So group 1, group 2, those are X, that's a Y, X, Y. Okay, always remember it's X, Y. So let's write out our equation. This is important for you to practice at least writing out the equation before you put it in a calculator, because if you don't write the equation out, sometimes we accidentally hit the wrong number on the calculator and we aren't verifying what we're doing. And we don't want to have a mistake just because we transferred the numbers incorrectly without just verifying that it was correct from an equation. So 84 minus 76 over 8 minus 6 equals. So I would first put in my calculator 84 minus 76. So 84 minus 76 is going to give us 8. And then the next thing I'd do in the calculator is I would just go 8 minus 6, or if you know that already, that's perfectly fine, 2. So 8 over 2. 8 over 2, I could go ahead and that would help me graph it if I need to, or that simplifies. 2 goes into 8 4 times. So it simplifies to 4. So the rate of change in high temperatures was 4 degrees a day. From the 6th to the 8th, it changed about 4 degrees a day. So question C says, during which of these time intervals did the temperature rise faster? Well, I have 0.8 degrees a day or 4 degrees. Which one is a greater increase? So remember, increase is getting bigger. Greater means more. So which one is the greater increase of this? It is between June 6th and June 8th at 4 degrees a day. So here is another example of what you're going to see. You're going to see a graph that's going to ask you to go ahead and find a rate of change from different points. And there's 2 different ways you can do it when you see it on a graph. One, you can look at it and remember M equals rise over run and simply count out the change, or you can use y2 minus y1 over x2 minus x1. So you can use the slope formula. Using the slope formula, you're going to have to just plot the points. So for A, let's just look at the graph. Okay, so 1 is here, so I rise. So if I go from 1 to 4 hours, I'm going to go from here up. So from 60 to 160 is 100. I know this is a positive slope. And then from 1 hour to 4 hours is 3 hours. So 1 hour, 2 hour, 3 hours, 3 hours. So my slope is 100 over 3, which simplifies, if I put that in a calculator, to 33.3 repeating. And I see that miles over here on my graph is what I know. So that is miles an hour. Now for B, find the rate of change from hour 8 to hour 10. So from hour 8, which is here, 8 to hour 10, which is here, what is the rate of change? Well, I could go ahead and just count it, or I can input it into the slope formula. Okay, so the first thing I need to do is figure out what points are the coordinates at. So this point, 8, I know is my x value, and my y value is over here, well, halfway between 360 and 460 is 410, because I noticed that this is an hour or 100 from here to here. So halfway in 2 spaces for 100, so each space is worth 50. So 410. And then this next point, this top point, is at 10, comma, 460. So now, group 1, group 2, y2 minus y1 over x2 minus x1. So I had 8, comma, 10 is group 1. And then 10, comma, 460 is group 2. Putting that information into the equation. So 460 minus 410 over 10 minus 8 equals 50 over 2. 2 goes into 50, 25 times. So it works out to be 25 miles an hour. That is the same. I could have looked at it and went, okay, it goes up by 50. 50 is my rise. 1, 2, 2 is my run. That would have landed me right here. And all from there I would have had to do was simplify.